All right, we continue with my chain rule obsession. Number 12 asks us to find the equation for a tangent line for this function. That is a lovely composition, right? We can see we have our nice cube, but inside of it is something a little bit more. You could algebra your way out of this in power rule if you wanted to expand that cube. That seems like a lot of work. So I'm just going to go ahead and do my chain rule. So if I want to find the equation for the tangent line, I know I need y minus y1 is equal to mx minus x1. We've been given our x1. We know y1 is just going to be whatever g of 1 is, and we know m is going to be g prime of 1. So let's go find our derivative of our g of x. There's our chain rule, 3a down in front, make that a square, and then we'll do the times the derivative of that inside function, which is a 4x. If I wanted to make this cuter, which we eventually need in the next problem, we could go ahead, use the associative property to make that a 12x times this 2x squared plus 1 quantity squared. All right, so there's our g prime of x. We need g prime of 1, so let's go ahead and plug that in. We'll have 12 times 2 plus 1 cubed, ew, which is 12 times 3 cubed? Really? I'm just regretting life choices right now. Yeah, really? I don't know. We'll see. We'll see. I'll check my work. I don't have a there's calculator. I'm not doing this math in my head. Just making that clear. 3 cubed is 27 times 12. Really? Really? I don't know. 324 according to this. Okay. And g of 1 is equal to 2 plus 1 cubed, which is 27. So barring I haven't made a mistake, which I am not feeling super confident about because these numbers are gigantic, here we are. Cute. Yeah, I'm not going to check my work. I lied. But there we go. So the next question here, still staring at this because I'm like, I can't be right. But I still don't see any problems. All right, so the next question asks us to determine any points at which this might have a horizontal tangent. So horizontal tangent, this is when our slope is equal to 0. Vertical tangent will be our slope is undefined. So we need to just take our original g prime of x and set it equal to 0 and find out what x values would have this happen. I saw a lot of us, I think, got distracted by the fact that we already had a tangent line and its slope wasn't 0. We couldn't really figure out what we were supposed to do with this. So 0 is equal to 12x times this 2x squared plus 1. Was that squared? Yep. Right, that was our cute version of it. Did I? Oh, that's where I made a mistake. I could, there it is. See, I knew I'd catch it. Squared. That makes more sense. I was like, this is too big of a number. 9. Not that 12 times 9 is any better. Still using my calculator, 108. I'm really bad at like copying down the same numbers from one line to the next. All right. So if we were to solve this, it's already factored. So you'd want to take something like, okay, when is 12x equal to 0? Well, it's equal to 0 if x is equal to 0. As we discussed in class, we could also set this piece equal to 0, which hopefully you could recognize faster. But if not, maybe you're getting all the way to here and then eventually getting to plus or minus the square root of negative 1/2 and realizing that this doesn't actually work. We can't take the square root of a negative number. So there's only one x value that would give us at a horizontal tangent, that is x is equal to 0, which we can then plug back in because it does ask for a point. So we need to know what the y value is. So g of 0 is 0 plus 1 cubed, which is 1. So the point at which we have a horizontal tangent is 0, 1. All right, so that was 12 and 13, complete with a lovely transcription error by yours truly.